From watching the last video, you now know what dehydration synthesis is. You know it's a type of anabolic reaction, and you actually could read this formula. You know that on the left side of that arrow is going to be the before situation, and that molecule or those molecules will be called the substrate or the reactants. And on the right side of the arrow, that is going to be what happens after the biochemical reaction, and that gets called the product. So in dehydration synthesis, the word synthesis shows that you're taking two smaller things to make one larger thing, and dehydration because in the process, a water molecule will leave. Why? Because it kind of got in the way of connecting that carbon to that carbon with a single oxygen. So dehydration synthesis. This is another way of looking at dehydration synthesis. Dehydration synthesis is used by the human body to put together the monomers of monosaccharides to make a glycogen, and it's used by the body to create other polymers. So here we've got monomers. This one's 3 monomers long. This one's 1 monomer big. And you're going to see that this oxygen and hydrogen, along with this hydrogen, they need to get out of the way so that this monomer can be directly attached to that monomer. 2 small things, 1 bigger thing. Great. Dehydration synthesis. Now pay attention, because the one catabolic reaction that you need to know is called hydrolysis. And again, we've got hydro, right, which refers to water. Hydrolysis is exactly the reverse reaction from dehydration synthesis. With, here, let me just go here. With dehydration synthesis, we started with this plus this, and we made this. With hydrolysis, we'll start with this, right over there. We'll add a water in, and we will create 2 smaller things, right? So if you need to be able to find dehydration synthesis among a series of images, right? First, you'll look to see if it's dehydration synthesis. You start with 2 things that are smaller, you make 1 larger thing, right? And water is going to leave. And with hydrolysis, it'll be the opposite. Okay? By the way, hydrolysis reactions, when you digest your food, it's all hydrolysis reactions. All righty. So far, we've been talking about carbohydrates. We now know that complex carbohydrates are good examples of polymers, that the monomers that make up complex carbohydrates are called monosaccharides. Monosaccharides are sugars, but things that are disaccharides, 2 rings stuck together, also get referred to as sugars. What's our next biomolecule? The next biomolecule will be fats or lipids. Oh, I'm sorry, you can't see all of this. Let's move me, all right? Fats or lipids, those are also organic molecules, and they are also simple. Most of them are also made just out of carbon, hydrogen, and oxygen. Here's the thing, though. You have got a lot more carbons than you have oxygen. Remember, I told you that in a carbohydrate, you've got the same number of carbons as you have oxygens, and you've got twice as many hydrogens, right? Well, let's look here at a typical fatty acid. Here we've got carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 carbons, and only 2 oxygens. Definitely not a carbohydrate. What's another way you can recognize that this is not a carbohydrate? Well, it's not in a ring or in a chain of rings. These are long chains of carbons all stuck together. So fats are made out of carbon, hydrogen, and oxygen, just like carbohydrates, but they have a lot fewer oxygens and more hydrogens for each carbon. So, now fats or lipids, they are not polymers. But if I were going to ask you, what is a typical building block for a fat or a lipid? The answer I'm looking for is fatty acids. These 3 things, this guy, this guy, this guy, These three things are all fatty acids. Let's break that down. Why are they fatty acids? Well, first of all, they are acids because if I put them in water, they will release that hydrogen ion and they will make whatever solution I put them into more acidic. That's only a small detail right now, but near the end of lab, when you're doing your digestive system labs, it's very useful to know that. So fatty acids. They are fatty acids because you find them in fats or lipids. Because if they're not exactly monomers, but they are the building blocks of a couple of very important fats. Fats don't dissolve in water. We were talking about this earlier when we were talking about polar covalent bonds. Fats don't dissolve in water. Why? They are non-polar. Because they are non-polar, they won't dissolve in water, which is polar. So here I've got it in writing. Fats are not really polymers, but they're often made out of fatty acids. Let's look at these two lipids. These two lipids are good examples of triglycerides. Triglycerides are the version of fat that is most commonly found storing energy in the human body, and it's the most common fat that is in our food. You probably have heard that fats fall into the category of saturated fats, which are not as good for the health of our hearts, and unsaturated fats, which are sometimes very good for the health of our heart. What's the difference between a saturated fat and an unsaturated fat? Before I talk about that, let's actually talk about the nature of triglycerides. Triglycerides, let me get out my pen. Triglycerides are made when three fatty acids, three fatty acids, 1, 2, 3, get attached to a glycerol. Okay, so 1, 2, 3 fatty acids. This is 1, 2, 3 fatty acids attached to a glycerol. All right, so triglycerides. Triglycerides are the most common form of fat in your food, and also a good way to store fat in the human body. So these are both good examples of triglycerides. Now, the one on top is a saturated fat. On the one on the bottom is an unsaturated fat. That's not random. Let's look at that a little more closely. Okay, so this is a stearic acid. This is one fatty acid. And you can see that out of all of the carbons that it has, every one of those carbons has only a single covalent bond to the adjacent carbon. See, one line. And then, since carbons can form 4 covalent bonds, those other 2 covalent bonds are holding on to hydrogens off to the side, right? Let's compare that with this lipid. This is linolenic acid, and this is an unsaturated fatty acid. Let's look at this one. Here we can see these guys are all single covalent bonds, but right there, double covalent bond. Here, double covalent bond. Here, double covalent bond, right? This particular fatty acid has got 3 areas where adjacent carbons are attached to each other by double covalent bonds. And what does that do? A couple of things. One thing it does is it makes it so that this carbon and this carbon, instead of holding on to 2 hydrogens, each of them is only holding on to 1 hydrogen, right? On top of that, you can see that because the carbons are attached to each other, see, these carbons, the way they're attached, they're like kids playing Ring Around the Rosie, right? They're holding hands and dancing in a circle, metaphorically, right? But what's going on here? Here, the carbons are holding on to one hand and one foot, okay? Doesn't make a good Ring Around the Rosie game unless you've got very coordinated children, right? These little kinks in the chain of carbons in a saturated fat And this one is the saturated, I'm sorry, that's wrong. Let's just erase all of this. The stearic acid is the saturated one. This one's the saturated one. This one's the unsaturated one. In an unsaturated fat, there are little kinks in the chain. That does a couple of things. One thing it does is it makes it so that saturated fats are very likely to be solid at room temperature. That is why you can leave a stick of butter sitting on the table and it will stay as a cube of butter because it is saturated fat. Whereas you can't do that with olive oil. As a matter of fact, if you had olive oil in a bottle on the counter and you went to pour it and it was solid, you would say to yourself, yes, something's weird in my olive oil container, right? Saturated and unsaturated. So what are saturated fats saturated with? They're saturated with hydrogens, okay? So the structure of triglycerides, they're the most common fat. We already talked about saturated and unsaturated. Saturated fats are fats that are made with saturated fatty acids. And if there's even one unsaturated fatty acid in a triglyceride, it's still considered an unsaturated fat. And this is a question on the first exam. What's the best way for animals to store energy for the long term? If I've got extra calories in my body and I might not need them anytime today at all, I might not need them for a couple of days. The best way for me to store them is in the form of triglycerides because I can put the most calories in the smallest space in the lightest weight if I put it as fat. Your body's got kind of three energy places. It has got blood sugar or glucose that's right in your bloodstream. That's like cash in your pocket. It has got glycogen. That is like money on your debit card. Pretty easy to get to, but you can't. Well, it's pretty easy to get to, but not as easy as cash in your pocket. And then there is triglycerides. And triglycerides are like money in a savings account. It's good because it earns interest, but not that available to you. All right. We are going to start here at the beginning of the next video.